Hello and welcome to Sunny App Dev. I want to walk you through deploying a Node.js server which will accept HTTPS requests. We're going to deploy using GitHub Actions, and we're going to deploy it to an EC2 instance running Amazon Linux 2023. So I have a blog post accompanying this video. And basically all I expect you to have is a GitHub account, an AWS account, and for the HTTPS step, I expect you to have a domain name because we'll create a subdomain which will route to the EC2 instance. So there's basically three steps. First step will be to launch the EC2 instance on AWS and give it an elastic IP, which is actually a fixed IP. The next step will be to deploy the Node.js app, and we're going to set up GitHub Actions, so we'll have a workflow and a runner. And the final step will be to configure NGINX and HTTPS, but this will be greatly simplified with Certbot. So step one. So basically we're just going to launch the instance, and if you go to your AWS console home, I guess, click EC2, click launch instance, and I'm going to call mine my node app. Copy that for now. And Amazon Linux, 64-bit architecture, T2 micro. Don't forget to click create new key pair, and I'm just going to paste in the name here, my node app, maybe _1. I have recorded this a couple times. Save that and click create key pair. That should automatically go to your downloads folder, so you can confirm that. And also we're gonna allow SSH traffic from anywhere. You can change this specifically to only allow traffic from your IP address. We're gonna allow HTTPS and allow HTTP, and we can just click launch instance. So great. If we go back to instances and my node app is pending. Now the instance state is running. Great. The next step will be to do the elastic IP, and on the left hand side you have this elastic IPs option right here. Select that. Allocate elastic IP on the top right, and then click allocate. And once you've allocated the elastic IP address, so this is the new one, 3.218, you can just click the IP address, and here you can select associate elastic IP address, and you can choose which instance to associate it with, and we're going to associate it with my node app, which is the instance we just created, and then here click associate. And so associated successfully. If you go back to your EC2, select the one we just created, and you can see that this now is the public IP address of that instance. I mean, if you open it, we don't have anything yet. That's fine. What you can do next though is click this connect button up top and click SSH client, and then you're gonna run these commands to SSH into the EC2 instance. So copy this command, and notice I'm in the downloads folder already, and I'm gonna make the key pair file private. And the other command to run is actually to SSH into the instance. And here I believe you have to type in yes. You get a warning message, but all good. You're greeted with this greeting. So that is essentially step one. Congrats. Let's move on to step two. So moving on to step two, if we just scroll down in the blog post, which I will link in the description. The next step is to actually deploy an app and set up GitHub Actions. I'm just going to read this summary because there are a couple steps in step 2. And the first is to push a Node.js app to GitHub. I have a repo which you can clone, or you can come to the blog post and go through the steps of initializing the repo, adding all the files, creating the files, adding the files, and committing. I suggest you do one of those, but obviously you can also push whichever Node.js server you'd like. So first step is to push a Node app to GitHub. The next is to set up a workflow to deploy changes on each push. This essentially is going to be one YAML file with a job to run. And the next step will be to configure a runner to run all the jobs defined in the workflow. And finally, we'll test that everything is working by making HTTP requests to the EC2 instance, and we'll have PM2 run the server. So, I mean, it sounds like a lot, but let's just scroll down through this, and I will show you the code in just a moment. For the example app I have, so the first step is actually to save the environment variables which we'll use in the app as GitHub secrets. So before we jump into that, I'll quickly just show you this example server app that I have. I got it from the Express.js docs. Essentially, there's going to be 2 routes, one route to return the users and another route to return the repos associated with each user. We do have a logger middleware function, and I have a link to a Medium article that describes how to write this function, and from another author. I suggest you check it out. Pretty cool. Also, we have middleware which requires an API key, hence those environment variables. And these are the 2 routes. One route to send the list of users. When you go to /API-users and you provide an API key, you get that array of users. And then the second route is to get the repos for a specific user. So here, for example, the example request is /API/user//Jane, like so. So that is the server file, and note again, we have these environment variables, which we actually now want to store as GitHub secrets. So once you have your repository set up and you've pushed once, you have your files here ready to go, click settings, and on the bottom here you got secrets and variables, and you can click actions. And to save some time, I already added some of the variables. I'll show you how to add one. So new repository secret, and it's actually key 1 and ABC 123. If we check here, key 1 is ABC 123. Add secret. Okay, great. Now that we have the secrets saved, the next step, we can just quickly check in the blog post. We did this part here. And then the next step will actually be to set up the workflow. And perhaps I'll just quickly read this paragraph. The YAML code below sets up a GitHub Actions workflow named deploy on push. Here we go, deploy on push. That triggers on pushes to the main branch. So on push main branch. The workflow installs dependencies using Node.js version 20.11, and using the echo command saves the environment variables stored as repository secrets to a .env file on the deployed instance. So this is how I essentially push the environment variables to the EC2 instance. So you can see here, key 1 is now whatever is saved in secrets.key1, and then we echo it into a .env file on the deployed instance. And just before that, we're running an npm clean install. So what I suggest we do And here I reference the article where I got this example from, so you can also go take a look. So back in your repository, if we just go to Actions and set up a workflow yourself, and we're greeted by this page here, we can just copy and paste this. Yeah, just careful, it's a YAML file, so all the tabs and stuff matter. We can click commit changes. I'm gonna say create a new main YAML, confirm changes. And on your local repo, which I assume you've set up already, you can just do git status. So it's clean, but we can pull in that workflow file. Now you'll have this .github workflows directory, and then you'll have the YAML file. So yeah, I did expect you to clone the repo or initialize the repo yourself, and I didn't show you that step. So I apologize for that if that is confusing. Moving forward, the next step is to actually set up a GitHub Actions runner. So perhaps I read this also. A runner will run all the jobs specified in our workflow file. So we had one job which was doing the npm clean install and so forth. That's the job. We will go to this screen on github.com where our repository is, but just to be clear, the commands that are shown here you run on your EC2 instance. So just quickly check that you're still SSH'd into your instance. All good. And let's go back to GitHub. And so I believe we need to go to, so I clicked Actions, and then I got runners here. So I guess this is from previous, oh no, maybe not from previous, but you need to select self-hosted runners. Okay, so this one is from a previous recording. So make sure you click self-hosted runners and then click new runner, and then new self-hosted runner. And we're going to be doing this on a Linux machine, 64-bit. And so the first step will be to download the runner, to extract the installer, and then the next step will be to go through the configuration process. And finally, this step I suggest we hold off on, and we'll later have the runner run as a service. So it's always running in the background. So hold off on implementing this command. Okay, great. So let's run these commands now. The first one is to make this directory on our EC2 instance. That's good. And it also changed into that directory. The next step is to run this curl command. Let's paste that in. I apologize for all the screen switching here, tabbing. I'm not going to validate it, and I'm just going to extract the installer and copied. It's done. Extract. Going to let it do its thing. And while it does so, let's just copy the next one, and this will start the configuration process. Copied. Okay, and as I said, let's hold off on running the actual runner. Okay, good. And okay, so this is one of the errors that you might get, that this libcus's dependency is missing. So if we go to my blog post, I say that there are likely errors, and let's do this one, sudo yum install libic libic, I don't know how to say this package name, sudo yum update first perhaps, and then install the package. Let's just clear the terminal here, and let's run the configuration process. So you should be greeted by this screen here, and essentially I'm just pressing enter for everything. Enter the name of the runner group, enter, enter, and here note it's going to create a work directory for us. Click enter, and that is successful. That work directory is going to actually be created once we run the runner. And so back to the blog post, we've gone through all of that, and what I suggest we do here is to install NVM such that we have Node and npm on our instance, and afterwards we'll actually run the runner. So let's go ahead and do that. We did yum update. Let's install git. Let's run this curl command. Clear the screen, the curl command. So we download NVM. This is so we don't have to open and close our terminal. Close and reconnect to EC2 instance via SSH to start using NVM, or run the below command. So this is what we just did here. Good. And let's just confirm that we have NVM now. Check the version. And so you can install whichever version of Node you like. For this tutorial, I'm going to be doing 20.11, and I'm going to make sure it's consistent throughout, including making sure that's the same version on the EC2 instance and the workflow file. Okay. Make sure we're using it. And just as a double check, we can do like, I don't know, Node version. Okay. And now actually let's change into the directory of the actions runner and then install it and start it. So we're already here. You can take a look what's inside, and we can install, and then we can start it as a service. Great. And if we clear the screen, the next command should confirm that this service is now running. So it's this one up here, actions runners. Okay, so now this is kind of like the fun part. We can actually test the workflow. And so let's actually console log the environment variables to make sure they're actually get deployed correctly. So I'm gonna add these console logs to the end of our index.js file. So index.js. And then I'm gonna clear out the console here. Okay, and I'm gonna add these changes, git commit -m log envs, and then git push. Okay, let's leave the terminal open here. And so you can go to your GitHub, and then if you click the actions, you can see that this workflow is now running. And yeah, let's see if we get any errors at this point. Okay, no errors just yet. So that is successful. Let's see what I got in store for us next on the blog post here. So if it did deploy successfully and, everything's fine, we should be able to change into the root directory of our project and start the Node app. So we can change back to the home directory of the user, do all these CDs. Okay, so let's see what's going on here. Change directory into actions runner and ls-a into the work folder and into the node, and then tab again, and we can do ls-a. Okay, so now we're in the root directory of the project, and just to keep things moving along, let's just run node index.js. So that confirms everything, including the environment variables were deployed. To assure yourself, you can run cat.env and see what's in the env file. Okay, perhaps we just show this cat.env. Good. Okay, and then let's start the server again. And let's see what else there is to do. Okay, so the server is running, but how do we actually make requests to it, right? That was the whole point of deploying it, is so that we can make requests like this. For now, just HTTP, but we want to, for example, get our list of users. How do we do that? We need to open up, so from your EC2 instance homepage, navigate to security, click the security group link, and then edit the inbound rules. And what you should do is have a TCP connection on port 8080. Essentially, you just have to open up port 8080. And so let's go ahead and do that. I'll go back to AWS homepage, EC2, instances, the My Node app. Okay, and down here, this is what I meant, security. And this is the security group link I was talking about. Edit inbound rules, port 8080, and allow the connection from anywhere. Good, and then click save rules. Okay, great. So if we actually just go back to the EC2, go back to the instance, My Node app. Sorry, I just want to grab now, for example, the public IP. And I think the easiest way to edit the URLs here was just add a few commented lines. Let's do something like this. So let's copy this. And instead of what I have here, we just put in our public IP. Okay. Good. Copy that. Let's go back to our browser. And great, so we get the list of users. So that's a success. You can test the other routes to get the specific repos of a user, but we got this response, and that's what we were looking for. The final step of part 2 of step 2 is to have PM2 run the Node app. So let's do that. And PM2 is a process manager, so it's a bit more robust. If there's an error in the app, we'll try to restart it. And what we do with these commands is essentially that anytime the system reboots, PM2 will start up, and PM2 will run any of the saved processes, and we'll save the process as My Node app. So running the index.js file would be a process called My Node app, and we'll save it, and we'll make sure on any system startup it runs it. And so the first step will be to install PM2. Okay, so before I close this out, you can see that our logger middleware function was firing. So we, for example, made a GET request to dash users and we got the response. So great. Stop the server. Let's go back to the home directory of the user and let's do npm install pm2. Okay, so shouldn't have changed directories. And then from the root directory of the project, let's run the command. Let's run the command to start the PM2 process. Sorry, change directory into actions runners, work, node, and then node again. So we're here. Now run the PM2 command. Okay, great. Let's save. Great. And PM2 startup. To set up the startup script, copy and paste the following command. Great. And that's all good. And just one final confirmation that our process is indeed running. It is running. We're done with this. What I suggest we do next is actually add this PM2 restart command to our workflow file. So on each push, we actually restart the process. So you can just copy this entire new workflow file with these 2 new lines and push it. So going back to GitHub, going back to our repo, in our workflow file, all I'm doing here is just restarting the process on each push. And we just essentially added these 2 lines again. So the process that we created, we say, hey, PM2, restart the process each time this job runs. So save, clear, and okay, git status. Okay. And the workflow might fail at this point because the PM2 command might not be found on the EC2 instance. So let's take a look. So here we have the workflow running, and as you can see, it failed. And if we click on it, you can see in running those 2 new lines that we just added, it failed at that point. And if you expand that further, it says PM2 command not found. And so I believe in the blog post, I have a way to resolve this, which is basically just to create a symbolic link for the PM2, which is living in the NVM directory, to something that's recognized on the system path. So you can run these commands to make sure you're using, to make sure you just have this node version consistent in all your commands. So for example, we can check out where PM2 is. You can see it's in the NVM directory, and there is PM2. And so depending for you where PM2 is, you should run a command similar to this. Yes, I do have a Stack Overflow link to this error, so you can read more on it, read more about it. And so here we're creating a symbolic link. We can try rerunning that workflow. So rerun jobs, rerun all failed perhaps. Yes, so let's rerun this failed job. Go back to the Actions tab. Okay, great, success. So To confirm that everything is good, let's, for example, now take a look at the logs of PM2 when we make requests to the server. So let's start it. You can see that when our app starts up, it fires off these console logs of the environment variables. And now let's go back to the same route of users. Let's reload it once. Let's say reload it twice. So we made 2 GET requests, and here they are. Get /API users, response, and then the same request response again. So great. I believe that finishes step 2, and congrats, and you're on the last step now, so stick with it. Let's get started on step 3, which is to configure NGINX and HTTPS with the help of Certbot. So just reading the summary here, the first step will be to install NGINX with these commands below. The next step will be to create a subdomain and route traffic from the subdomain to the EC2 instance, so to that elastic IP address. The next step will be to set up Certbot, so to install it and have it manage certificates, and it will also configure NGINX HTTPS settings for us. So with a few commands, Certbot will do a lot for us. With regards to NGINX, what you have noticed now is that we're making requests directly to port 8080, and we opened that port up specifically, and we know that our Node app is running there, and we're making requests directly to that port. NGINX will actually serve as an intermediary between those requests, and what I mean is once we have set it up, if we scroll down here, it will be like the web server, and it will act as a reverse proxy, meaning it will be listening on port 80, which is the default HTTP port, and it will forward requests that it receives there to where our Node app is running. And our Node app is running locally on port 8080. So that's the NGINX part. So let's go ahead and install NGINX, start it, enable it, and then start it as a check the status of it below here. So install, start it as a service. Make sure we run this command as well. And let's check the status. And if you just expand the terminal a bit here, it says that this configuration file, which we'll edit in just a moment, that the syntax is okay and the test is successful. So those are all good things. So let's clear out the terminal again. So actually at this point now, you should be able to navigate to the public IPv4 address of your EC2 instance and see a greeting from NGINX. So let's just copy this URL. Let's edit it to just be like so. So we can specify port 80, or which is a default port for HTTP, or we don't have to. So it's up to you. So let's say we do something like this. Going back to here, let's close that out for now. So you see we're greeted with, and you see it automatically removes the port 80. So we're greeted with the NGINX welcome screen. That's great. Next, like I was saying, let's edit the configuration file, and we're on Amazon Linux 2023, and this is where the configuration file lives for us. If you're doing this on another version of Linux, it might be somewhere else, but what you have to do is, again, to change the server block within the configuration file to look like so. And what will that give us? It will give us it will now pass the requests directly to our Node app. You'll see we'll just specify HTTP and it will directly forward the requests to our Node app. So I'm going to copy everything that's within the server brackets. Well, first let's just copy I apologize. Let's copy this sudo nano command. So now we're within the configuration file, and it should look like so. And so, mindful of the brackets, we will delete lines. I will delete lines with Control K. We can remove this location block. We can also remove this one, this error page. This you can leave or you can remove. I don't think it matters. Delete, delete. Even this. This will leave. This will delete. And actually, let's just delete everything and copy and paste it from the blog post. So you're just left with an empty server block. And we'll just copy and paste this in. And here on a Mac, you should be able to just do Command V. And then to save, Control O, Enter, and then Control X to exit out. And like I was saying, we can restart NGINX to check the status. To then check the status. And everything is still good. Syntax is okay, test is successful. Clear that out. And so let's make a request to a URL like this. So let's just copy this. And where are we editing the URLs? Here. And so let's just tack on this dash API part, and let's get rid of port 80. Get rid of this. So now we can make requests like this. So this is progress for us. Now instead of this, okay, so when there's a request to the public IP address of our EC2 instance on port 80, which is the default HTTP port, it's successfully forwarding those requests to our Node app. Okay, great. And so then the next step is actually to route traffic from a subdomain to the elastic IP address of the EC2 instance. So essentially what you have to achieve, whether you're doing this on Amazon Route 53, as I will do here, or you're doing it with another domain name manager, you have to create an A record for a domain that you already own. So for example, you own mywebsite.com, and what you need to do is create an A record which points from this subdomain to the IP address of your EC2 instance. And so I think, as I have here at the end of this step, we will be able to make requests to not the public IP address, but we can make requests to this subdomain test, for example, .sunnyappdev.com, and then our usual route to get the users. And then we will generate HTTPS, like we'll generate the required certificates for this subdomain name. And that will get us HTTPS. And I just wanted to say, I'm doing this for Amazon Route 53, but you might be doing it for, let's say, GoDaddy. And so there was obviously a lot of blog posts that I read when I was putting this together. And one of the good ones that I wanted to show you was this one. The author is SaaS Scale Up, and there's a YouTube video for this GitHub repo, and you can just look up this link and look up maybe Node.js SSL server on YouTube. And this is where I learned that it's a good idea to PM2 save. So save the process and run PM2 startup to make sure PM2 starts up on system boot. But what I wanted to show you was that the author goes through setting up an A record in GoDaddy. So if you want to take a look. So yeah, don't be discouraged just because I'm doing this with AWS Route 53. Just find maybe a tutorial for this specific part and just get it done. All right, let's go. So for those following along with me, let's go back to AWS and now let's go to Route 53. Let's click hosted zones, and you can see I already have a hosted zone for the primary domain name, and then we're just going to create a new one, and I'm going to call it the subdomain is now going to be node.sunnyappdev.com, and so it's a public one. Create hosted zone. So we got this green banner here. At this point, if we just here we just expand the details of the hosted zone, we just have to grab these name servers, copy that, and now let's go back to the hosted zones, and now we need to add these as name server records in the primary domain name. So we'll go to sunnyappdev.com and we'll select create a record, and record name is going to be node.sunnyappdev.com, and then the values will be these name servers, and it's going to be a name server record. So that you can change this if you like, something like 800, and select create records. Okay, good. So if you click back to hosted zone now, now all we need to do is actually, as I was describing earlier, now we just need to create an A record to point to the EC2 instance. So at this point, the subdomain and the primary domain are connected, and now we just need to have an A record to route traffic from the subdomain to the EC2 instance. So to do that, as I was saying earlier, it's going to be an A record, and we just need to grab this elastic IP that we created, this fixed IP, and we need to include it in here in the value field. And again, we can change this, and click create record. Now, if we go back to the blog post, did this, the final step is to add an A record, as we just did, A record. And at this point, we should be able to make a request not to test, but node.sunnyappdev.com. So I think I have just wrote out the URL here just to save a little bit of time. So now if we go back into the browser and we do that, you can see, yes, we're going to node.sunnyappdev.com, and we're still getting that list of users. Okay, great. And honestly, I hope you're still with me, because now we're going to move on to the final step of setting up HTTPS. And like I promised, it's going to be greatly simplified with Certbot. And yeah, let's just see what it says here. The first step is to actually just edit that configuration file again, and just to change it to the server name. It was localhost before, to change it to whatever your subdomain name is now. And for me, that's going to be Node. So I guess I'll copy this. Make sure you're still SSH'd into your instance. and back to the configuration file, the NGINX configuration file. And here I am gonna say, I am just gonna delete this out. So Command V on a Mac, Control O, Enter, Control X. Okay, you're good to go. And now we can go ahead and install Certbot. Perhaps before you do that again, just scroll up through your command history and maybe restart NGINX and check the status one more time, just to make sure you don't have any typos. And NGINX is still okay. Okay, great. Let's clear that out. And where are we now? Okay, so to install Certbot, let's run this command. Okay, and then this will take us into the configuration process. It should ask for an email address and a couple other prompts, so let's try to get through that. Okay, enter an email address. I'm gonna say node.sunnyappdev@gmail.com. So, I mean, feel free to provide a correct email address. Please read the terms of service. Let's say yes. Would you be willing, once your first certification is successfully issued, to share your email address? Let's just say no here. And we did that last step, changing the configuration file such that this now appears. So this should your subdomain name should appear here also. So I'm just going to enter 1 for that. And it's now requesting a certificate. And it's saying it is now successful in doing so. And what we can do is a dry run of certificate renewal, so we can test this command also. So let's clear that out. So, okay, while it does that, my next step really is just to explain to you that how the configuration file will look like. It will be one HTTP block, and within the HTTP block there will be like 2 server blocks. One like so for your subdomain name, and another another server block within that HTTP block, which will redirect any HTTP requests to HTTPS. So this server block handles HTTP requests by redirecting them to HTTPS. Okay, so let's let me just confirm that for you. So congratulations, all simulated renewals were successful. So I hope it's successful for you too. Let's go take a look again quickly at this configuration file. And so you can see our ugly formatting is still here. And then look, it added these SSL certificates for us. And you can see the comment on the right-hand side of managed by Certbot. And we have any HTTP requests being redirected to HTTPS. Okay, good. So we can exit out, Control X. Like I was explaining, since the second server block is redirecting, it's listening on port 80 and redirecting any requests, any HTTP requests to HTTPS. In our security tab, I believe we can leave the HTTP port open, but we can close the port 8080. So let's just review the inbound rules of our instance. let's go to EC2 and instance running back here. So the security tab that we are familiar with now, the security group, and let's edit inbound rules. And so I will leave this HTTP port open, leave the SSH port open, obviously leave the HTTPS port open, which was that first server block, which was listening on port 443. And I just delete this custom TCP one and save rules. And as promised, let's now, I'll leave this just in case. And now we can add HTTPS. So we're going to the HTTPS of the subdomain name, which is routing via NGINX requests to that Node app that we have successfully deployed. And what we should get again is our list of users. So let's see if that is true. And yes, it's HTTPS and we're getting that list of users. And just to prove to you, if we do an HTTP request, it should again be redirected to HTTPS. Again, redirected to HTTPS, and we get our list of users. So so some further things you can do. You can read more about SSL and TLS and it's Amazon documentation. You can take a look there, and this link you can run a test of your server. Just enter your subdomain name in there. And yeah, thank you for watching. I hope this video was helpful for you. Make sure to check out these other blog posts and documentation, and if this video was helpful, I don't know, give it a thumbs up and subscribe. Thanks a lot.